To Math 31, this is a continuation of the factoring review, titled Factoring Review 2, and we're going to look at two specific types of factoring. First off, grouping, and then division. Now, factoring by grouping you may have done before in one way or the other. Basically, it goes like this. When you're dealing with four-term or higher polynomials, one method you can use, and you often will try, is to group in order to break it down. It doesn't work for everything, but it does work for quite a few. So when I see something like this, 2ax plus bx plus 2ay plus by, the very first thing that I would look for would be a common factor for all four terms. And you may not get that, though, and in this case you do not get it. So I'm going to try a 2 by 2 grouping. And it simply means that I will group the first two and then the second two. Now, you're probably thinking out there, well, what happens if I rearrange it? Well, the way it works with grouping is you should always try it the way it is, first off. If it doesn't work, then try switching around, because two of the three configurations should work. And it's possible that you might have to do some shuffling. But always try it the way it is. And then you look for a common factor in each of the little groups. So 2ax plus bx, I see that an x can be factored out, leaving me with 2a plus b. So I write it as such. And then with the second one, I could see a y can be factored out. And that would leave me with then 2a plus b. And this is the key step, because if you get it set up so that they both now have a common factor of a binomial, 2a plus b, we now factor out the 2a plus b, and when you divide that from both of those clusters, you'll be left with x plus y. So there you have it. You have now factored fairly quickly this four-term polynomial. I want to remind you that it doesn't work all that often in the grand scheme of things, but it's a good idea to have a look to see if you can before you try anything more extreme. Now here's two more questions requiring that, so let's go through them and see if there's anything insightful that emerges. So once again, for this first term, or this first expression, there's no common factor that can be removed from all four. So I'm going to, out of desperation, I'll try a 2 by 2 again. So a squared minus ac, I now factor an a out, and that will leave me with a minus c. And then the second cluster, I can factor a b out. So really there's nothing particularly new happening here, just an a minus c. And at this stage we factor the a minus c out from both terms, and that will leave you with a plus b, and we're done. Now number 3, looks pretty routine, and it is actually fairly routine, but you look for that common factor all the way through. I don't see it, so a 2 by 2 makes sense for us again. The only thing that's a little different now is with these negatives, but I don't think that's going to shock anybody. I can only factor a p out from those first two, so divide it out and I get 3m plus 2n. And then the second one, here a factor of 4 can be removed as well as a q, and your decision is whether you take a plus, positive, or a negative out. And keeping an eye towards the idea of matching this binomial, we take a negative out. So when we divide that out, that's going to become positive 3m plus 2n, and that's exactly where we want it to be. So 3m plus 2n divides out, factors out of both of those clusters, leaving you with p minus 4q. So be aware of that. Try a couple more. Now, with this problem, I don't think you're going to see much exciting happen, but you will see that when you do a scan across the entire thing, we can actually take a common factor of 3 out from each of those terms. and that's it. But that's good because that will give us, well, might be good. It will give us 7 m squared p squared minus 14 np squared plus m squared minus 2n. And now we just go to work on the inner expression. The 3 sits outside as a passenger, and then this first grouping of 7m squared, the 7 comes out, can be divided out, and I think we can also remove a p squared from both of those terms, and that should leave us with m squared minus 2n. And then the next one, interestingly, there is no common factor that can be removed from m squared minus 2m, but we still need to indicate that we are taking out a factor of 1. And then that will leave us with simply m squared minus 2n, like that. And then the 3 again is outside, and we get m squared minus 2n get factored out, and then we have 7p squared plus 1. Now, that's okay the way I have it, but there's a bit of redundancy with respect to the brackets. So I will now write it as 3m squared minus 2n, and then 7p squared plus 1. The number 5, only thing that's noteworthy about this problem is that we have 1, 2, 3, 4, 5, 6 terms. And I don't believe we can take out a common factor from all of 6 of them. So we try a 3 by 3 grouping. So normally with grouping, you do try to keep it 2 by 2 or 3 by 3, 2 by 2 being the most common. And then you hope for the best inside the expression. So 2AP minus BP plus 2AQ. If I understand that one right, from the configuration that I have, there's nothing that's going to be coming out of that one. And then there's no common factor of A. There's no 2 that's coming out. There's no P even. So then I turn to the second one, minus BQ minus 2AR plus BR. And we don't have anything going on there either. So you could just give up, or you could try rewriting this expression. And now we just hope for the best. So without really knowing what I'm doing or where I'm going with this, I'm going to take that 2AP plus the 2AQ and minus the 2AR. And I did this because I see those 2's and for no other real reason. And then I can write it in any real order, minus BP minus BQ plus BR. Now, there's no guarantee that this is going to work, but it does at least give us a setup where something might be, at least we might be able to make some steps towards it. In actual fact, a 6-term polynomial having any sort of factoring would be fairly rare. But let's see what we can do with it. So I look at this 3 by 3 now, and I can see, okay, finally, 2a can be factored out, leaving me with p plus q minus r, if I see that correctly. Now the second cluster, there is a b that can come out, and I will keep it, I'll take out the negative b, because if I do that, if I divide by negative b, that leaves me with p, then plus q, divide by negative b, gives me minus r. And amazingly, this one worked out. So our answer is actually, I'll write it to be consistent, by factoring out the p plus q minus r, will leave me with 2a minus b. So we got lucky, I guess, with this one. So that's grouping. Now the next little video clip will concentrate on a more common factoring method, which is the factor theorem and division. But I'll stop this one right now. Thank you for your time.